In this module, we will be exploring exponents and the rules of exponents. There's two terms that are key to exponents, the exponent or the power itself, and the base. The base is the quantity that is being raised to the power or exponent. So 2 to the 4th is 4 factors of 2, or 2 multiplied 4 times. Note, sometimes our base is a larger expression like 5x. There are many rules we need to know with exponents. The first is the product rule. The product rule says when we are multiplying like bases, we add the exponents. So notice here, we have 7 squared times 7 cubed. 7, our base, is the same in both of them, and we are multiplying. So we have 2 factors of 7, or 7 times 7, times 3 factors of 7, 7 times 7 times 7. And what we will do is we will add then those exponents to see that we have 7 to the 5th. We can do the same thing no matter what our base is. As long as that base is the same, we can add those exponents. So x plus 6 to the 4th times x plus 6 to the 9th equals x plus 6 to the 13th. The quotient rule for exponents says we will be subtracting the exponents when we have like bases being divided. So here, our like base is 6. We have 6 to the 5th being divided by 6 squared. And you can see if 6 to the 5th is being divided by 6 squared, 2 of those 6's will divide away to 1, leaving 3 6's being multiplied, or 6 cubed. Therefore, our rule says we can take 6 to the 5th minus 6 squared. 5 minus 2 is 3. Be very careful that you do not divide those bases away. So 9 to the 12th divided by 9 to the 8th is not 1 to the 4th. We have to recognize that this is 12 9's being multiplied and divided by 8 9's. So 9 to the 12th divided by 9 to the 8th is 9 to the 4th, not 1 to the 4th power. Exponential expressions that are raised to the 0 power. Anytime an exponent is raised to the 0th power, it equals 1. So 5 to the 0th power equals 1. But we really have to always wonder, what is being raised to that power? So in our second example, 5x to the 0th, only that x to the 0 is being raised to the 0 power. So that equals 1. So in essence, you have 5 times 1, which equals 5. This differs a little bit from the quantity 5x raised to the 0. Here, everything in that parentheses is being raised to the 0 power, so that equals 1. It doesn't matter whether we're working with numbers or with variables, we still have to wonder what is being raised to that 0 power. So our last example, s is being raised to the 0th power, but r is not, so you get r times 1, which is r. Our power rule for exponents tells us that when a power is raised to another power, we multiply. So 3 to the 4th raised to the 6th power is 3 to the 4 times 6, or 24. This is because we would have 3 to the 4th times 3 to the 4th 6 times. And using our addition rule, we would see that 4 plus 4 plus 4 added 6 times together is 24. Therefore, when we have a power raised to another power, we can multiply. In the power of a product rule, what I'm going to look at is distributing that exponent to anything within inside the parentheses. So 5x to the fourth we can look at as 4 factors of 5x, which is 5 being multiplied 4 times x being multiplied 4 times, or 5 to the fourth, x to the fourth, which simplifies to 625 x to the fourth. Similarly, we will have a power of a quotient rule, where our exponent n gets distributed to both our numerator and our denominator. For example, when we have 5 divided by x to the fourth, we can see that as 5 divided by x multiplied 4 times. Looking at this then, we see that that is 5 to the fourth divided by x to the fourth, or 625 x to the fourth.